company like ours. Historically, some of the incumbents are a little afraid. They feel it might commoditize their data, but really what it's doing is driving demand, and that flywheel starts turning, and that's good for everybody who's part of the ecosystem.
Yeah. Anybody else have any thoughts on the topic?
I think Joel has hit the main points in terms of the challenges related to data distribution and logistics. It's really interesting to think of, just the idea, we don't know what we don't know. We don't know what we could do. So, if data was widely available, what smart person in Canada, around the world, could come up with some very innovative analytic or data product or insight that nobody's ever thought of before. And so I think it behooves both industry and government to do their bit to improve the logistics and to improve the distribution and uptake of data. So, perhaps as a small example of some steps that the GHGSat has taken in that regard, we have taken the initiative of putting together an interactive global methane map called Pulse. You can go to pulse.ghgsat.com. And you got this little slider there, and you can cycle through basically the last couple of months of global methane data and actually zoom down to about a 2-kilometer grid, and really addressing what Joel has talked about in terms of the interest in small area and point sources of phenomena of interest, which is exactly the area that we play in. The other thing that GHGSat has done is that we've come to an agreement with CSA and ESA to make 5% of the data from IRIS, GHGSat C1. So this was our first operational satellite that was launched back in September. So there's actually an announcement of opportunity available on the ESA Earth. It's earth.esa.int. And if you go to the AO section there, you'll see the solicitation for researchers to put in proposals to make use of that data.
Thank you, Eric. Stephen, Curtis, you guys like to chime in?
Oh, sure. So I think, again, echoing what people have said, if the data is available, a bunch of smart people find really interesting things to do. I think one of my favorite examples of that is I met a guy called, I think it was Daniel Cuson, who's doing bridge monitoring with synthetic aperture radar. And I guess now that RCM is available, the revisit rate and the fidelity is high enough that he's a researcher, and I guess he found this way to monitor the condition of bridges. And going back in time with some other SAR tools, you could see there's the bridge in Italy which collapsed, and they showed that you could actually see you could have predicted that if you had this SAR tool. So I think kind of like what Eric was saying, and Joel, if you have that data available, you really don't know what people are going to do with it, because there's so many creative people that'll think of really interesting ways to develop these interesting applications, but the availability of these data sets is still lacking. So that's really the problem Wyvern's trying to solve with our constellation, is that if we can fill in another piece of the electromagnetic spectrum, then you're going to have some traditional applications which you can kind of predict people will use, but then there's all these other applications that you just don't know yet what people are going to do and what kind of interesting things they'll discover.
I guess if I may, I'll echo what Eric and Curtis and Joel said. That's what CERCO observed in Europe on the Copernicus program. We managed the data distribution for Copernicus and Sentinel data. And, in 2-3 years, we're up to 275,000 users downloading the information. We're talking petabytes of information. And what they create out of that EO data is fantastic. And we don't know what we don't know, but as you give, I like to express that EO data, when you give it out, it's like a bag of chip. You take one and you just can't stop. You just explore and you just want more and more and more data. And I think the YASA model is interesting, as you don't need that huge server or that huge equipment. You can actually do it in the cloud. So you don't need to download yourself petabytes of data. You can actually do what you want to do with the data without having to invest hugely in computer system and work it out. But since we got the contract in 2017 for YASA, we've had a hard time keeping up with the demand, the growth. So we've been refreshing and growing just to make sure that everybody has access to all the Sentinel data and can actually process, turn it around for farming, COVID-19. You talked about the bridge in Italy, or water monitoring, water levels, etc. So yeah, making EO data available to the industry is, I think, a very good thing to look at in Canada.
Thanks for that. Thanks for the input. Stephen, if you have any comments, we can.
Sure. I can just add, just a short bit, but it also depends on pricing. How attractive, and easily accessible is this data, for typical academic budgets or even company budgets, and this also opens up the wonderful possibility of merging these types of data sets with different types of EO data sets and ground-based and airborne data sets to come up with applications that right now are unknown to us. And so it's an exciting time, and let's keep pushing forward on making the data available and relatively cheap or inexpensive.
Yeah. So I just want to kind of take a little pivot. Erica, you mentioned GHGSat, the pulse with your methane. I want to kind of go each one in your company. So Wyvern, Skywatch, FortPilot Lab, and GHGSat. What's one of the most, I guess, interesting use cases of your company that you currently can provide or plan to provide in the EO field? We'll start with Curtis at the top.
Oh, thanks. So that's a really interesting question. So Wyvern, we're planning to start as a data distributor. But some of the use cases we've started to explore is a lot of farm-related ones. So we're looking at moisture mapping, starting with some more basic analysis, and then moving more into, can you identify certain diseases such as clubroot? That's something we've been looking at. Clubroot is a disease of canola. And I guess I didn't know anything about farming before I started this company, full disclosure, but I've learned a lot about farming in the past 6 months. And apparently canola is this really devastating disease that affects farmers all across Canada. And if you had hyperspectral imagery, you could actually identify it before it becomes serious, and you could treat it. And another interesting one is looking at tailings pond monitoring, especially with moisture content. So if you could identify areas that have higher moisture, then that's important to oil and gas companies, as well as vegetation monitoring of pipelines. And this is another interesting use case. Sorry, I can't help myself, but apparently pipeline companies and transmission companies care a lot about vegetation around their pipelines and their transmission lines. They do that because they want to know if that vegetation is going to grow into their assets, or if or a whole bunch of other things. So there's I guess the two, if I'm going to pick two, it would be for farming. There's just a ton of really cool use cases, specifically the clubroot one I thought was fascinating. And two is vegetation monitoring around pipelines and transmission lines, which is this huge problem that nobody's really addressed yet, but is still out there. And right now it's being addressed by a guy going around on a quad, which is probably not the most efficient way of doing it.
Curtis, great minds think alike, because that's those are two that I was thinking about as well. The vegetation encroachment is really interesting. We've got some customers that are actually getting down to the tree level and trying to model the tree to see if that's growing. So if you get high enough resolution, you can do that. It's pretty interesting, and it's transmission lines and, like you said, oil and gas pipelines. And it seems like for us, the most interesting use cases of our customers are the ones where people just save huge amounts of money. So you talked about oil and gas pipelines as well. And, in a lot of countries, there's regulations where you have to monitor these pipelines on a regular basis from above. And fortunately, from above, satellite imagery, Earth observation data qualifies. So what we're seeing is companies going out there who are using open data like Sentinel-1 SAR data to do change detection, and then queuing up high resolution satellite imagery, because it's simulating the helicopter pilot leaning out over the pipeline and looking and seeing there's a bulldozer getting kind of close. He's going to take a picture, send it back to the office, and then they'll send boots on the ground. You can imagine just doing that all automatically through a tip and queue mechanism with open data and high res commercial satellite data saves like 75% for these companies. So those are the use cases that that really excite us.
Yeah, Stephen, Eric, would you like to speak about?
Yeah,
Stephen?
sure. Yeah, I can pitch in. So, 4PI we're not a traditional image providing EO company. We provide real-time alerts, of very small wildfires, and so that's our main business model, is to provide basically a subscription service where we send the coordinates and the threat level of an alert to the people managing the affected areas. However, we do have use cases that extend our technology to be amenable to real-time search and rescue, because we have the ability with our technology to spot safety flares from space. And so this is of importance to the Canadian government, especially DRDC, as well as other types of organizations involved in search and rescue worldwide. We also have the ability with our constellation to provide real-time alerts of very small harmful algal blooms. And so, from wildfire alerts to to this amazing different sets of use cases, our technology is finely tuned to bridge that gap.
And Eric.
GHGSat has, as I said earlier, we have 2 satellites on orbit now, with third satellite, Hugo, scheduled for launch early next year. So what's really exciting for me, having recently joined this company, is to learn all the things that, not just, use cases, but things are actually going on in practice as we speak. So, for example, since the launch of GHGSat's first satellite, Claire, in 2016, we've been working with COSIA, the Canadian Oil Sands Innovation Alliance, to characterize greenhouse gas emissions from oil sands operations in Alberta. We've also been working very closely with operators of shale gas wells, primarily in the United States and in other jurisdictions as well. One of the interesting things I found out, again, being new to GHGSat, having been here for 3 weeks, that I wasn't aware of, is that really there's only a handful of these wells that account for something like 50% of the total, greenhouse gas methane emissions in the United States, which is kind of a remarkable thing to think about, when I believe there's something like over 500,000 gas wells just in the United States alone. And this speaks to Joel's comment earlier about the benefits of remote sensing and Earth observation from space to get this coverage, which in many cases would not be practical to send a human being down, to each and every gas well or each and every kilometer of a pipeline on any sort of regular basis. The other use case that, again, was new to me, being new to the company, but I found quite fascinating, was measurement of methane emissions from hydroelectric dams. So, I always thought of hydroelectric dams as being something that was a very green energy source from a climate change standpoint, and they absolutely are. The challenge is that there's often a lot of suspended biomaterial in the water. And as this material basically goes through the sluices and starts frothing and becoming turbulent, and this gas is released into the atmosphere. So these are some of the things that we've been able to measure, first with our satellites, and most recently, of course, we have an airborne platform as well for more detailed observations. I will mention one last case I found really quite fascinating, which happened last year, in which our Claire satellite was actually trying to, or did characterize, what's called a mud volcano in Central Asia. This is basically, it's like a pocket of natural methane under the surface that kind of bubbles up in sort of like a blister. And so, our science team was looking at that, and completely serendipitously, it was like, whoa, there's actually another emission in this image. So on the next pass of the spacecraft, we sort of self-tipped and queued, to use Joel's terminology. And what we found in Turkmenistan was an emission that was at the time one of the largest known methane leaks. And because we were able to do that, operators and the responsible authorities were able to take action.
It's interesting. Thanks for that, Eric. I just want to pivot again to another topic, and this is definitely 2020. So COVID-19, how has the impact of COVID-19 affect, the Earth observation market in Canada or abroad, in terms of perhaps hindrance on funding, development, or perhaps positive development in, technological advancements, data acquisition, the market altogether? How has COVID-19 shaped EO in Canada? Yeah, Stephen, I'll start with you.
Sure, I can take that. So in terms of EO, there's always a need for EO, but the funding, of course, from governments or other groups have been slowed. But also, the market itself is still growing. But what we found is our interaction with our vendors. And so we take hit when it comes to the timelines of developing the hardware we need to develop our technology. However, when we work with good Canadian groups, for example, Iridian Spectral Technologies and Delta Photonics, these two Canadian groups are doing the best, to get around, the impact of COVID, and to provide us with the hardware that we need to test our equipment, sooner than later. However, our international partners are more affected by the COVID situation and less able to dance around some of the issues. And so basically it's our vendors, our funding, but the EO market is still growing.
Mm-hmm. It's great to hear.
Yeah, if I may, I'd actually like to refer back to Dr. Tanya Harrison's excellent presentation yesterday, showing some of the planet imagery and how they've been able to characterize some of the effects of COVID-19. I found it absolutely fascinating. Things like looking at cars in parking lots or traffic on highways. And I think the one that was the most interesting example that I think that Dr. Harrison cited was some of the imagery they took around Venice, and basically the increasing clarity, the reduced turbidity of the water as a result of reduced boat traffic, through the canals and through the different bodies of water. In terms of things like funding and financing, we are, of course, in a global crisis right now, and the first priority is to address the pandemic. But it's also appropriate, and many people are thinking of this now, that what happens after the pandemic? What is the world going to be like post-pandemic? So while we take the necessary and urgent priorities to address the pandemic in the here and now, it is also appropriate to start thinking ahead in terms of what happens after and building back better. So, we've been very fortunate at GHGSat that there hasn't been a noticeable impediment in terms of support. So as an example, we were absolutely thrilled to announce back in September that we had closed the first tranche of our Series B funding to the tune of $30 million. And looking out in the community, this is not an EO example, but other ventures like Astroscale, for example, have also demonstrated an ability to continue to secure financing even in the midst of the pandemic. And I think the reason for that is, as I said, while we continue to deal with the urgent priorities of COVID now, there are other societal priorities like climate change, like space debris mitigation, which have not gone away, and that we will have to address when we build back better after the pandemic.
Mm-hmm. Yeah, Curtis and Joel, if you have thoughts, yeah, you can chime in.
Sure. Yes, I think Stephen hit it on the head when he talked about the funding. There was definitely a bit of a freeze in the early days of the pandemic, we were fortunate in our timing. We closed our Series A. We announced that early in 2020 before that all started. So we were lucky, but it seems like that's starting to loosen up a little bit more. And actually, in the early days, it kind of it reinforces some of the things I said earlier, where we saw companies looking to save money on activities they'd normally do in person or would involve travel. So, people got creative. So, for example, a U.S. company who certifies organic farms, they used to, be on site at all of those locations. They couldn't do that during the first lockdown. They turned to us to see if we could help. We saw lumber companies doing some similar activities, word of mouth or observations, keeping an eye on stock of their competitors, changing to Earth observation for that. Installation of solar farms and the monitoring of that, correlating product warranties and maintenance. Solar farms, when the sun goes across the sky, the panels move, but if one's broken, it doesn't. So you can identify that and those kinds of things. So in terms of demand, I think we've seen it increase from our side. And in terms of funding, I feel like we're over the hump. I think everybody's adapting now to the new normal. So I think the opportunities are there and coming back for business models that support this remote observation environment.
Mm-hmm.
I definitely agree with what Joel said. I think rightfully a lot of new funding was going towards COVID related activities. So a lot of the funding that you normally see for startups was paused. I would I also think that companies maybe are looking towards doing more automation type work, and EO really falls into that bucket about what can you do without having people going out to locations to look at things if you could use satellites at a reasonable cost. So I think that that got companies thinking a little bit more about what they could do with EO data. Maybe some of these companies are beginners at that, and somebody like Skywatch is the perfect company to help them get introduced to Earth observation data.
Just before our Q&A, I just want to throw out one last question about early this year, CSA announced or discussed the Canadian space-based Earth observation strategy. And so the question I'm going to pose is that, should Canada be more reliant or self-reliant on EO, and how can we, achieve that down the road?
Sure, I think it would be good for Canada to be more self-reliant on EO, especially in a few key areas. I think developing some partnerships with other countries will still be important, because you can't put all the sensors into space, but especially focusing on one or two, that's important to Canada considering our large landmass. So I think synthetic aperture radar will continue to be important for Canada. I know in the US and in Europe, there's been a few companies, and in Japan, that have come out with commercial SAR constellations. And it'd be really cool to see someone in Canada or somebody listening here to start a Canadian SAR constellation. But I think, and also, in optical, it'd be great for Canada to maintain some of its optical capabilities. So I think key to this will be Canada essentially picking a few parts of that EM spectrum and maintaining capability in that, while building partnerships in the areas that it doesn't have that expertise or capability.
I'll echo what Curtis is saying. Obviously, Canada's a leader in SAR. We've got a lot of respect in the world for historically what we've accomplished. And I think, I agree with Curtis for strategic interests. Obviously, we want internally self-developed, self-sufficient capabilities. But I think the other piece to think about is we need to be able to leverage the vast array of commercial data that's out there. And often it can be built cheaper, delivered faster, and can be more iterative than could be done with government programs. And tied to that is leveraging cloud computing. It was brought up earlier, but we've seen directives from the Treasury Department on mandating cloud computing first. And so we're seeing that sort of spread across the government of Canada, albeit a bit slowly. And then, really commercial operators like the ones on this panel, again, can innovate really, really fast, orders of magnitude faster and orders of magnitude cheaper than any government project. So being able to combine all of that data in our view is going to be really strategic for Canada. and then obviously have that segment of it that is really strategic, that is focused on our national interests.
Mhm.
Yeah, I'd like to tie together the great things that Curtis and Joel said by referring back to one of the recommendations of the Space Advisory Board, which called on Canada to have a balanced space program. And I think this is something that's particularly pertinent to the EO field, where we need the big flagship government programs like RCM. But in a balanced program, these things should be complemented and augmented with other capabilities. So, for example, smaller class missions like WildfireSat, which is now in phase A, which is of strong interest to people like Stephen. We should be leveraging international partnerships. So, for example, potential Canadian involvement in the EU Copernicus program. And we should also, as Joel said, consider leveraging the capabilities of the commercial sector, commercial data providers, commercial data purchase in the model, for example, the NASA commercial smallsat data program or the ESA third-party mission program.
Stephen, yes.
Yeah, great. So agreed on all fronts. The three people before addressed it perfectly. And also, we have to emphasize Canada's big. And so it is in our best interest, especially, from a national perspective, to develop our own Indigenous EO expertise and capabilities. But we at 4Pi, we're also, big fans of the, space-based Earth observation strategy, because we hit basically 4 of the 7 points bang on. And so, climate change action being one of them, because our constellation of satellites, we're hoping in less than 5 years to basically dramatically reduce the number of catastrophic wildfires worldwide and help curb the effects of climate change. And so we are big fans of the SBEO, and yes, let's do it.
That's great. So I want to move on to our Q&A portion of this panel. We got quite a few questions from the group today, and anybody could chime in. First one we have, what are the possible hazards to Earth observation due to SpaceX's constellation satellites, and how do we overcome such problems? Oh, there we go. And the questions are shared on the screen.
And may I ask for clarification of what do you mean by hazards? Is that collisions, or is that contamination of the EM frequency?
Well, let's talk about potential collisions. Start with that as a hazard. Yeah, let's say collisions and maybe an overpopulation of satellites within the low Earth orbit.
And so for us, it's to choose orbits that minimize that risk. Where most of the people or SpaceX are putting up their constellations, and generally there's the people are will be operating in the lower part of Earth orbit, and so by choosing a band of altitudes that minimize that's probably the best way to go, or to choose orbits that minimize any possible interaction. Space debris is a real issue, especially with the thousands and thousands of satellites that are scheduled to go up, and so it's that's a great question, and it's a real concern, especially for those of us wanting to put up constellations.
Yeah, I proposed putting lasers on our satellites to shoot down our competitors, but unfortunately that idea was nixed by my co-founders. But so I think this is like an interesting problem, because it's never been a problem in the entire history of the world. Like, there's never been too many satellites, but now this is like a fun problem, because there are probably more satellites than anyone ever thought would be possible in low Earth orbit. So I guess the hazards are, one is there's a hazard to the astronomy community that's been well documented. Astronomy will be affected. Two, the risk of collisions, I think, will probably still be negligible, just because it's such a low Earth orbit is still quite large. And three, I guess, another hazard is just the spectrum. So if you have a lot of LEO broadband constellations, you're just going to run out of space physically. So how do we get around that? Maybe optical comms, maybe something else, maybe like network type solutions where you have mesh networks in space. But I think those are all pretty far out, and I think they can be addressed, but it'll be really interesting to see what happens.
Yeah, and I'm certainly no expert in this area, but there are companies like Leo Labs and others that are specializing in this, that are trying to orchestrate collision avoidance. And so I think we'll see more of that, not just with SpaceX's constellation, but with others, because part of it, as you probably can imagine, in this problem is the orchestration has to be with everybody involved. You know, if there's collision avoidance going on from both systems, really ideally they're coordinating between the two of them. So having that broker of all of those things, I think, is going to be really important, whether it's something like SpaceX's constellation or others.
I'd like to just fit in one more question before we wrap up this panel. The second question on the board. So what updates are needed to the Remote Sensing Space Systems Act or other regulations to make it easier for each one of your respective companies to operate? And you can go just down the list. Who would like to start?
Well, so I just read the RSSSA, so I feel very well qualified to answer this because we're putting in our application, and I think so it's actually not too bad. Like, it's very similar to the ITU one. I think there's areas where you could reduce the amount of information, or but the main problem, I think, is that the amount of time it takes to apply and then to get the license can be quite long. And some of the problem is that you need very detailed specifications about your constellation, and you might not have that a year and a half in advance, especially with CubeSats, because a CubeSat could theoretically be designed, launched, and operated within 6 to 12 months if you're really, really quick. So shortening that time a bit, I think, would be the biggest advantage, and then perhaps changing some of the information in there so you could apply and maybe get like a pre-approval pending some additional details being filled in would be super helpful.
Yeah, I agree with that, Curtis. Yeah, the RS cubed A situation, it's heinous, but it's in there to, for the industry. But if they can ease, some of the regulations to allow us to apply sooner than later, that would help.
From our perspective, we support companies that are going through this process. We don't have to necessarily go through it ourselves, but there's a couple of interesting pieces of it, I think, right now. One that I think the government brings up a lot is there's basically a ministerial veto or approval process, so the minister can get involved if there's an exception that needs to be made. So that sort of can override a lot of the pieces of the act if there is something that doesn't make sense with new technology. The other piece is that it was written a long time ago. It is updated, it is reviewed a lot, but it was also written under a different lens, I think, with defense and with security in mind, that doesn't always jive with a lot of the commercial interests of operators that are applying for it now. And what's encouraging is we are seeing our neighbors to the south with the NOAA approval process, efforts to streamline that. So as Curtis was saying, if you could go through something like this in 3 to 6 months, and echoing what Steven says, then maybe it would be easier because you would have more of those answers that maybe you don't have when you have to apply for it 18 months out.
So it seems like time is a big hindrance. Eric, yes, please.
As a 3-week guy at GHGSat, I don't have a lot to say. If there's a specific question, I'd be happy to convey it to my colleagues on the regulatory team. Perhaps I will mention that regulatory modernization is a pillar of the Canadian space strategy. So it's something that the government of Canada is taking very seriously and looking to how best support all of us here in industry from a regulatory standpoint.
Yeah. I'm going to squeeze in one question, actually, since we have just a few minutes left. This question, should we go for an international EO with all space powers? And I think the question is asking, should nations be collectively have an EO organization, or is there benefits of being independent? Canada has their own independent EO sector, then, different space powers have their own independent EO sectors. Do you think it's better to be separate, or do you think an international EO would be more beneficial?
Well, I would argue that by its very nature, Earth observation is already very international, and there are entities already existing like GEO, the Group on Earth Observation, who have a mandate to coordinate international efforts and basically sort of build up an international system of systems. Maybe I'll tie it back to an earlier question on the panel about Canadian self-reliance in EO. The truth of the matter is that Canada has never been entirely self-reliant on EO. Environment, ECCC uses primarily NOAA data for its weather forecasting, for example. So, international collaborations, international partnerships are actually critical to everything that Canada does, both in the EO domain and in space in general. And that's true of all of our international partners as well.
Joel?
Yeah, sorry. I think as Eric said, basically we're international already, but if you draw a parallel to almost the Canadian music industry and how there's and television for that matter too, there's certain requirements the government mandates about the content that must be supplied. And of course, we're not going to do that in EO, but it shows that funding a particular sector can have a big impact on it. There's a lot of Canadian musicians and shows that are wildly successful because of a program like that. So our participation in ESA obviously has been very successful. Canadian companies get exposed to a lot of opportunities that they wouldn't if we weren't involved in that. So I think it's going to have to be a mixed bag. We're seeing obviously manufacturing in China, manufacturing of sensors and spacecraft is probably the cheapest in the world by most accounts. So whether we have just one international space organization, I think that's probably a bit of a stretch, but partnering with space agencies like European Space Agency that give us opportunities, I think that's going to be really important for Canada to continue.
Well, we're running out of time, so I'm going to just wrap it up right there. Thank you, Curtis, Eric, Stephen, and Joel for joining us today. Hussein, I'm going to throw it back to you.
Well, I can't say that I'm not happy with this panel, guys. Thank you so much to all of you. For the ones who are first timers, we hope to welcome you back. For those who've been here before, thank you so much once again. It's always an insightful conversation, as some of you mentioned that we are a leader in this, in some sorts, in this industry. So a virtual round of applause, and we hope that next year we can host you folks again on the Canadian Space at the Canadian Space Summit. On behalf of the Canadian Space Society, thank you so much for coming. And for anybody that has any questions, if any of you folks will be at the networking session later, please feel free to ask the panelists about their insights into their specific industries and their specific topics of discussion.